So welcome to today's coffee lecture, which is on a connected paper, a bit of a different way to explore scientific literature. And I will give you a quick overview and show you what it can do. But first, I want to introduce you to the Tarzan method. You might be familiar with it or not. Tarzan was navigating in the jungle with the liana, so that's a means of transportation. And for using the Tarzan method in literature search, you use one paper that you start out from, and then you can go either to the past by looking at the reference list, so that's the backward citation chasing, or you look into the future, which is here, and you try to find other papers, newer papers that have cited your original liana. And you will see why this is important in a second. So that gets me to connected papers, and now I will do a live demo. So that's what this looks like when you start it. And we also need some key publication here to start with. So I copy in a DOI, and then you see the paper is listed because it automatically suggests the title, and then it takes a second to build a graph. So what do we see here? First, we have a graph of papers. I'll talk to that about that in a second. Then on the left side, we see these things list as a list, and we can look at the titles of the respective papers. But we can also just mouse over, and then we see more details on the right side. So here we can look at the title, but also the abstract. We can even expand on the authors. And now what exactly do we see here? And I think that's the key. So relating back to what I just said with the Tarzan method, this is not a citation map. This is not a citation graph. But what is done is basically we look at a lot of related literature that has similar citation patterns as my starting paper. So my start paper has been cited by some papers, it has cited some papers, and now there is a big citation graph in the background, which is not shown. And with that, we look at which papers do have similar connections, or maybe similar connections around the corner that maybe jump one or two papers more. And that's what we see here. So if a paper is closer to our original, and the original is highlighted here in the middle, then there is more closeness. So if it's further out, it will typically mean it's somehow more different. And we can also see, so if I mouse over that paper, one additional line appears, and it goes via this. This is the preprint to that paper. That's why they are so close. And also, if we go in a little bit, we see here a line, and that line also says something about the closeness. So the thicker the line, the more related a little bit, or the stronger the linkage is. Then what else we can see is that some of these circles are a bit bigger, others are smaller, and that is just the citation number. So that's an additional piece of information that we get. For example, here, this is smaller, it has 1 citation. The original paper has 8 citations, and then here that has 24. That should actually be bigger, I think. So I think there's still some room for improvement to make that more quantitative and quicker to grasp. What we also see that some are darker, and we have a legend down here at the bottom. So the darker, the more current the paper is, the brighter, the older. So you, because sometimes you also have some of these clusters that, yeah, for example, here, that's maybe deemed a bit older, but I mean, we don't go so much back. So I think also with the gradient here, it's not quite linearly scaled. Then, so this is just that similarity graph, but what you can now also do is look at some of these communalities. So maybe older work that is somehow related to all of these papers that are deemed similar. And that's what we see when we click here on prior works. And then we get a list of papers, and we can see We also have citation numbers, and we have the year and some information, and we can also on the right side always look at more information. So that is one way to maybe find key older papers that are those are not shown in the graph. But I could, for example, now click on that, and then we see on the left all these papers that are shown in the graph. They cite this paper that I've selected here. And if I go now back to the graph view, then we see all these here that are marked now in blue, they cite this source from back in the day. And we can do the same with derivative work. So that is more going into the future, even though not all or not always are they newer than the original papers. I found somehow, so it doesn't always quite work. But then also here we can click and then see, well, now I just have one highlight. Oh yeah, there's one, two down there. And again, I can close that, and that should be marked somehow. I think that's now this one here, but it's now not so clear. So these are some of the things we can do. And then we have a list view. This list now relates to all the papers that we see in the graph. And here we can also look at the similarity. And then we see similarity is quite low. Just for one paper, it's 39. And that's the most close paper. And that's actually the preprint where this publication is based on. And then it drops down quite dramatically. We have some filters. So for example, we could reduce the year span that we look at. We can also, I mean, now there aren't any PDFs available, no code, but a lot of them is open access. So that could be something. And we can export these via download, and then we get a file that we can import into a reference manager. So we could work on there, or maybe even download the papers from within the reference manager without having to go to the publisher's side. And then I want to show something final. What we could also do is a keyword search. So I'm now searching for deliberate practice. And this is something I find doesn't work so well because the tool somehow isn't cut out to do it, because we get some hits that contain these keywords. But then, well, it says chose a paper to build a graph. And then the question is, well, why am I now shown this paper? Is it because it's really well connected in the graph? It's because it has a high citation number. And if I go through, so this doesn't have such a high, this does have, this has 16 citations, this here's 67. So it can't be that, but I don't really have a clue. How is the ordering, or why am I shown this paper first and the other one second? So I think for this use case, it's not really cut out. And with that, I think I already come to my conclusion. So this could assist you in finding new literature that is maybe related because it has a similar citation pattern, and that could be helpful, for example, if other people that worked on something similar have used different words to describe what they are doing, but then they build all up on the same work in the past, and maybe also other work in the future is built on that. And so that's the communality. And so that could mean that you are working in the same area, even though you use different terminology, and that you would not find via a simple keyword search. So that could be one thing. It's an alternative to the typical approaches, just using language to find papers. You can export it. I do find it has a number of drawbacks. It's an exploratory tool. The algorithm is maybe non-intuitive to grasp, because if you look at the graph, you don't really know what it means or how it came about. And this algorithm also might change over time, and then you couldn't really reproduce what you now saw. I found when using the tool, it's highly dependent. Some papers give nice results because somehow there is a citation similarity with other papers, and you do find something, and with others you don't find anything at all. Especially if a paper doesn't have a citation yet, then of course the whole path into the future is not given. so you don't have that. And keyword search doesn't work. I also maybe would add to that that you already need to know a bit about the field to then be able to judge, well, do you find anything good or not? So it's maybe not the first tool that I would use if I were to enter a new field, because then it's very difficult and very hard to judge because you get similarity, but it's a limited set of similar things because it's only similarity in citation pattern. And with that, I'm at the end. There is a digital coffee lecture card that you can download, and I will just pop the link also in the chat. So people who join remote can also have a look at it. And then I'm happy to take questions. And I also want to highlight that tomorrow, the next coffee lecture is going to be about access engineering, a tool for chemical, but also other engineers. And with that, I want to thank you for your attention. Thank you very much.